Welcome to the part 2 lecture of small signal analysis of common emitter amplifier. Here I have taken the common emitter amplifier circuit diagram. Here the common emitter configuration is biased using the voltage divider bias. This is the general common emitter amplifier. So this R1 and R2 makes the voltage divider circuit, which will be used to bias the VBE or the base emitter junction. The voltage divider R1 and R2 supplies the required voltage for VBE, which is 0.6 or 0.7 volt depending on the transistor. So how to draw the small signal equivalent model for this circuit, or how to analyze it, that we will see it in this video. So let us start from the transistor first. Let's draw the small signal model of the transistor first. So the small signal model of the transistor is already discussed in part 1 lecture. So let us take it as this is the small signal model by drawing HIE, and the other parameter at the input side is HRE into V0. So this is the base terminal, and the common terminal is the emitter terminal, which is common for both input and output side. And in the output side we have HFE into IB as the current source or collector current, which is equal to the collector current. Parallel to the current source we have the admittance or resistance value, which is inverse of the H0, 1 by H0. This is the small signal model of common emitter transistor. So the common terminal is the emitter terminal. Here now we need to connect all other resistor values. So in this small signal model we have VCC, which is the DC supply. So the small signal model is nothing but the AC model. So we can ground this DC, or we can short circuit the VCC. This is mean killing off the DC sources. The first condition is killing the DC sources or kill DC sources. This is the first condition to draw the small signal model. So here the VCC, this is the only DC source which energizes the common emitter amplifier. So we have short circuited the VCC or connected to the ground. And the next condition is based on the capacitance value. The small capacitances, all this capacitance can be short circuited because capacitances allows the AC. So all this capacitances can be short circuited. All the capacitances are short circuited. So when all the capacitances are short circuited, at the emitter terminal we have the resistance called RE, which is parallel to the short circuited terminal, short circuited capacitance. So this is also grounded. So there is no RE now, the emitter is directly connected to the ground through this short circuited capacitance. And coming to the base terminal, in the base terminal we have two resistances, R1 and R2, and the VS is short circuited, Vin is connected to the base terminal. So two resistors and a voltage source. The R2 is connected from the base to ground. So ground is the emitter here, so directly we can connect. So this is the R2, and R1 is connected to the base to VCC, where the VCC is short circuited now. So this R1 is connected like this from base to ground again. Sorry. R1 is grounded. Through parallel to this, the voltage source is connected, which is referred here as Vin. This is up to the input side or at the base terminal. From the collector terminal, collector resistance RC is connected, where this is connected to the collector to VCC. Again VCC is grounded, so we can draw as disconnected to collector to emitter. Then through the short circuited C0, RL is connected to the ground. So from the collector, RL is again connected. So now this is the small signal equivalent model of the given circuit. The given circuit is drawn like this in the small signal model. So Vin is the voltage source, small signal voltage source, and R1, R2 are the biasing resistances. And this is your small signal model of your small signal model of common emitter transistor. Small signal model of common emitter transistor. RC is the collector resistance, RL is the load resistance. Now we have already seen the small signal analysis of common emitter amplifier, where the common emitter amplifier is drawn with the general RS as the source resistance and RL as the load resistance. Now instead of RL, the RL can be replaced here by RC and RL. This RL is replaced by RC and RL, and in addition to that, with the input impedance, we have also added two more resistances called R1 and R2. So this can also be written like this, that is the same parameters. The four amplifier parameters can be modified by adding the input impedance of the amplifier is taken as ZIA. I will be naming it as a new variable ZIA. Input impedance of the amplifier is taken as ZI parallel with, this is the ZI or the input impedance what we have already calculated, and at this point we have calculated the value of Y0 output admittance. So this can be now it is modified, ZIA is modified as ZI parallel with R1 parallel with R2, and in this the RL, instead of a single RL we have included RC also. So RL can be written as RC parallel RL. These two changes we have to do it in the common emitter circuit, general circuit parameters. So once you have done all these things here, that is replacing RL by RL parallel RC, RL parallel to RC, and replacing ZI, that is ZI is this value. So ZIA will be, that is amplifier input impedance will be the ZI parallel with R1 parallel with R2. So wherever we have the value of ZI, even AV we have ZI, ZI can be taken as ZIA. Other than that, this RL can also be taken as RC parallel RL. By substituting all these things, we can get the common, we can get the small signal analysis of common emitter amplifier in this voltage divider bias condition. Thank you.